Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring how to graph absolute value functions. Before we do that, let's look at a couple of definitions. An absolute value function has the form f of x equals a times the absolute value of x minus c plus d. And when graphed, will form a V-shaped graph, which will have a minimum value when a is greater than 0, and will have a maximum value when a is less than 0. So the function f of x equals negative 1 times the absolute value of x minus 1 plus 3 is shown below. Use the graph to answer the questions. Question A, the function is symmetric about the line. Well, we have a line, imaginary line, going through the vertex of this function right here that cuts the function into two mirror images. And this line in this problem is x equals 1 because it passes through the x-axis at x equals 1. We call this line the axis of symmetry, which I'm going to abbreviate AOS for axis of symmetry. All right. Now, the vertex is sometimes referred to as the turning point, and it would be either at the very top of the V-shaped graph or at the very bottom. So in this case, the vertex is at 1, 3. The y-intercept will be where the function touches the y-axis. So in this particular situation, the y-intercept is 0, 2. Now, this function has a maximum value, because it opens down, of 1, 2, 3. This is the maximum value of 3, and it occurs when x is equal to 1. Now, let's talk about where the graph is increasing and decreasing. So for what values of x is f of x increasing? So let me highlight the portion of the graph that's increasing. So as x increases from left to right, it's increasing on this portion of the graph. So this would be, and we want to tell the x values here, negative infinity to positive 1. Now, the graph is decreasing in this portion of the function. So that would be 1 to positive infinity. All right. So the domain of this function, on the left, we're going from negative infinity to positive infinity. So that would be all real numbers. And the range, our lowest value on the graph is negative infinity, and our maximum value on the graph is positive 3. So we're going from negative infinity to positive 3. All right, example 2. If we're given a function rule for a function, we can easily find the y-intercept algebraically, because the y-intercept occurs, let me write this down, y-intercept occurs where x is equal to 0. So if we evaluate a function at f of 0, then we will know the y-intercept. So here, f of 0 would be 0 minus 3 minus 4. So that would be the absolute value of negative 3 minus 4. Well, the absolute value of negative 3 is positive 3 minus 4. So 3 minus 4 is negative 1. So our y-intercept here would be 0, negative 1. All right. Problem B, we want to calculate f of 0. So absolute value of 0 minus 5 plus 3. So that would be the absolute value of negative 5 plus 3. The absolute value of negative 5 is 5. And 5 plus 3 would be 8. So 0, comma 8. All right, next problem. We want to calculate f of 0. So 2 times the absolute value of 0 plus 1 minus 3 would be 2 times the absolute value of 1 minus 3. The absolute value of 1 is 1. So 2 times 1 is 2. 2 minus 3 is negative 1. Now, what I'd like you to do is pause the video and try problem D on your own. When you're ready to check your answer, press play. All right, welcome back. Let's see how you did. I'm evaluating f of 0 here, so 1/2 times the absolute value of 0 plus 4 minus 5. So this would be 1/2 times the absolute value of 4 minus 5. So the absolute value of 4 is 4 minus 5. 1/2 of 4 is 2. And 2 minus 5 is negative 3. So our y-intercept is 0, negative 3. So in conclusion, when finding the y-intercept, just evaluate the function at f of 0. Now, when you're finding the vertex, you want to start by getting the x-coordinate of the vertex. And the way we do that is we set whatever's inside the absolute value expression equal to 0. So 3x plus 6 is equal to 0. Then solve for x. So 3x would equal negative 6, and then divide by 3. So x will equal negative 2. So now we know the x-coordinate of the vertex is negative 2. To find the y-coordinate, you're just going to take that negative 2 and plug it into the function. So absolute value of 3 times negative 2 plus 6 minus 4. So this would be absolute value of 3 times negative 2 is negative 6. Negative 6 plus 6 is 0 minus 4. The absolute value of 0 is 0, and 0 minus 4 is negative 4. So our vertex here is negative 4. Negative 2, negative 4. All right, problem B. We're going to take whatever's inside the absolute value symbols and make it equal to 0. Now we'll add 8 to both sides and divide by 2. So we know the x-coordinate of our vertex is 4 comma something. To find the y value, you're going to say negative absolute value of 2 times 4 minus 8 plus 2. So this would be negative absolute value of 0 plus 2. Negative 0 plus 2, which is 2. All right, hopefully you're starting to see that the y value of the vertex is always going to be your constant. So that's going to save us some time in our next problem. So in our next problem, we're just going to take whatever's inside the parenthesis, make it equal to 0, and solve. So I know the x-coordinate of my vertex is 3. My y-coordinate is negative 7. So 3, negative 7. All right, example 4. If f of x equals 3 times the absolute value of x plus 3 minus 2, find each of the following and graph. All right, to get the axis asymmetry, you're going to find the x value of your vertex. And remember, we said to do that, you take what's inside the absolute value symbol and make it equal to 0. So subtract 3. So there's our axis of symmetry. X equals -3. All right. Now I'm going to plot this with purple here. 1, 2, 3. So here is my axis of symmetry. Now your vertex must lie on the axis of symmetry. So we know the x value of the vertex is -3. We also learned that the y value of the vertex is this constant right here, -2. So I know my vertex is at -3, -2. So let me plot that. 1, 2, 3, 1, 2. So this is the turning point of my vertex. All right. Now it says use the value of A to plot the right side of the V shape. So in this problem, our A, we highlight it, is the number attached to the absolute value. So in this problem, our A value is going to be 3. We could write that as 3 over 1 because an absolute value is a V-shaped graph with one straight line going to the right and one straight line going to the left. This A value acts as our slope. So from the vertex, I'm going to move up 3, 1, 2, 3, and right 1. 1, 2, 3, right 1. So there's the right side of the V shape. Now I'm going to use symmetry to get the left side. So if this point is 1 unit to the right of the axis of symmetry, I must have another point 1 unit to the left. And if the top point is 2 units to the right, I must have another point 2 units to the left. All right? So now we did D, use symmetry to plot the left side of the shape. So I'm going to connect these now in a V-shaped graph. All right. So this graph has a minimum value of -2, and it occurs when x is equal to -3. So remember, your minimum value is your lowest y value on the graph. All right. For what values of x is f of x increasing? So let me highlight where it's increasing. It's increasing from here to infinity. So from -3 to infinity, the function is increasing. For what values of x is f of x decreasing? So this function is decreasing here. So that would be from -infinity to -3. It's decreasing. All right. So our domain on the left, our leftmost point is -infinity. Our rightmost point is +infinity. So this would be all real numbers from -infinity to +infinity. Okay. The range, oh, I'm sorry, it said write it in interval notation. So that would, in interval notation, we would have -infinity to +infinity. All right. What is the range in interval notation? Now, range goes from the bottom of the graph, which is at -2, to the top. So -2 is our bottom value. Infinity is the top value. So that would be our range. Example 5. If f of x equals -1/2 times the absolute value of x minus 2 plus 3, find each of the following in graph. In part A, they want the axis of symmetry. So take what's inside the brackets, set it equal to 0, and solve. So x would equal +2. So here's our axis of symmetry at +2. Now, once we know the axis of symmetry, we know the x-coordinate of the vertex also. And to get the y-coordinate of the vertex, it's just this constant here. So that would be 2, 3. So 1, 2, 1, 2, 3. All right. So there's our vertex. Now use the value of A to plot the right side of the V shape. So in this problem, our A value is negative 1/2. So from the vertex, I'm going to go down 1, right 2, down 1, right 2. That's about as far as I can go. Now I'll use symmetry to plot the other side of the graph. So I want to be 2 units away from the axis of symmetry here, and 1, 2, 3, 4 units away. 1, 2, 3, 4 over here. Now I'm going to connect my V-shaped graph. Looks something like this. There we go. Now this graph has a maximum value of 1, 2, 3, and it occurs when x is equal to 2. So for what values of this graph is the function increasing? Well, from here to here. So that would be negative infinity to 1, 2. And it would be then decreasing from 2 to positive infinity. So the domain in interval notation, again, would be negative infinity to positive infinity. And the range would be our bottom value of the graph is negative infinity, and the top value of this graph is positive 3. And that concludes today's lesson, graphing absolute value functions.